students, and I will try to give them 1 or 2 more minutes. Hopefully they can join us for the rest of this chapter. And today is our last day of class, as you know, and next week we have a final exam. So just, I will wait 1 or 2 more minutes. Hopefully they can come. Okay, I think it's better to start. I'm not going to wait more than this. As you might remember, last week we started slab design, and we went through example for one-way slab, and then I gave you tables for two-way slabs. And today I'm going to review those tables one more time very fast, and then go after the example. And today is our 16th weeks. So we had 16 weeks of classes, and with no holiday. That's one of the rare cases that we had no holiday or break during this past 16 weeks. Even one day, we had no off day for this course. So 16 weeks straight. And it went very fast, actually. For me, it looks like a month that we started this, and every week is going very fast. And today is the last day of class, and hopefully you actually this stuff in future and use them properly. Okay. Slab tables, and as you might remember, positive have 2 tables, one for dead load, one for live load. For M negative, we have just 1 table, and another table is for shear to find the load on either side of the support. As you might remember, LA and LB, L is the minimum side of the slab. So if you have 10 by 8, 8 is your LA. LB need to remember. Why? Because LA divided by LB, you can see, is equal 1 and less than 1. So it means that LA is the minimum side. You can't go with them. Yeah. So, and more clear. If you can see any, this kind of shadow around the support, yeah. If you can see that like this one, means that simple support. When you have simple support, means that there is no negative moment at this support, negative moment, no. And these are the factors for positive moment, yeah. And because of that, you can see you have numbers. If you have this actually all around is that 4 sides are fixed support. So you will get negative, negative, negative at support, positive. So and positive at 2 direction, positive this direction, positive other direction. So we call this A direction because this is LA. A direction, negative moment, positive moment, negative moment. B direction, negative moment, positive moment, negative moment. Yeah, hopefully it's clear. If not, please ask me. I will review this again and again. If you have just fixed at these two both sides, small sides, the long sides, you have no fixed support. So zero negative moment, zero negative moment, just for A direction, you have positive moment here. Yeah. So you will get just positive moment for this case. And for the other direction, you have negative moment, means LB, means B direction moment. So for B direction moment, you have negative moment, positive moment, negative moment. That's it. So if you have one long side fixed, one long side short side fixed, the other two are simply support. So zero negative moment at A direction, zero negative moment, positive moment, negative moment. For long direction mean B direction moment, zero negative moment, positive moment, negative moment. So, and you can actually find your case, you should be between one of these 9 cases. And these 9 cases are the same for tables. Yeah, those are identical for all tables. So for MUA means at this direction, MUA this direction, MUB B direction, LB B direction, LA A direction. That's the actually factor. Find CA for dead load, CB for load. All of them are the same as this. Just I make there. These are from actually my textbook that I published in a long time. And unfortunately, during the making copy and copy, it's not that clear. So I try to make one of them clear, and the rest they are the same. CACB, CACB, CACB. That's for dead load. Yeah, because these coefficients are for dead load only. So this for agent times omega u dead load means 1.2 times dead load times LA length of the short side in the power 2, and do the same for B direction with CB. That's it. As you can see, this is very easy to use. And for positive live load, do the same, just read these factors. Yeah, those are not the same as the other factors. So these factors for positive moment, live load. So 1.5 load times CA, this one, times LA square, or 1.6 live load times CB means this number, times LB square times C. That's it. So you can, then add them to LUA, dead load, plus LUA, live load, positive. You will get MU for A, positive and negative. Add them together. That's it. That's the moment that you have to design your positive moment for that case. And what's the length of the strip? You should consider 1 foot for this direction, 1 foot for other direction. That's it. Yeah, 1 foot this direction, 1 foot. So your B always for design of slabs, the easiest way for one-way slab and two-way slab should consider B equal 1 foot, 12 inches. And you know the thickness, so you can find D. And then go after that long equation that I gave you and find AS. So this is for MU negative, MU positive, add them together, MU dead load positive, MU live load positive, add them together, you can find MU positive. Then design the steel based on that moment. For MU negative, just one equation for dead load and live load. Dead, live, both of them 1.2 dead load, plus 1.6 like top of all the actually tables. You cannot actually forget this, because you can see moment coefficient is for dead load and live load. Add them together, DL. Then go again, some LA over LA, find the negative. These are the factors for the support, because negative, you have simply support, so there is no negative moment, and because of that, there is no factor. I hope it's clear. For A direction, no factor. For B direction, no factor. No CA negative, no CB negative, because simply support. For here, for CA negative, there is no support. Actually, it's simply support. So there is no CA negative factor. But for B direction, this long side, you have fixed support. So you have CB negative. What about here? One side is simply support, another fixed support. So you can see no negative moment at A direction, positive moment we have, negative moment at the other. So this one, this negative, this coefficient is for negative at the A direction. Other side, mu is 0. This factor is just for shaded side for this one, because the other side is simply support. So negative moment, 0. Negative moment here, this is the factor, times omega u d 1.2 dead load plus 1.6 live load times LA square. Do the same for the B side. That's it. So right now, you know why there is no number here. Yeah? When there is no number at the B direction, you can see no B direction, because simply support, there is no negative moment. For A direction, one side of the A has negative moment. This factor is for negative moment other side. So this side, 0, because there is no fixed support here. So you can read these numbers, hopefully. Yeah, if you have question, ask me, raise your hand. I will review this again to make that completely clear. And this is the load transferring. For fully disconnected. Can you hear me now?
Yes, Professor.
Yes.
Perfect. Very good. Thank you. Just want to double check to see if the connection or not. Okay. So I want to find the load that is transferring to A and B direction. So WUA at the A direction means this direction, means the load will come to this support and that support, A direction. Okay. We should find omega A. That's what's that? That's the factor here. The factor omega A and omega B. And what's the omega U? Omega U dead load plus omega U 1.2 dead load, 1.6 live load. Okay. So we know LA and LB times total dead load, live load, that times this factor means 0.5 times LA times LB times omega U means 50% of the load will go this direction. And as you can see, this two direction, it means that you have load here and load here. So if you want to find the shear, divided by 2, because whatever you calculate this is the total load going that side and this side of the A direction. So divided by 2 means the load at this side, that's the total load here. If you want to calculate that for 1 foot of that, that's total of LB. At the A direction, you have LB, total length of the A direction is LB, just remember. So that load divided by 2, divided by LB will give us the total reaction for 1 foot at the A direction. Remember, one more time, omega UA is, let me show this with this pen, maybe it can help. Right now, that's the slab that we calculated 0.5 for this case, 0.5 times LA, LB times omega U will go this side and that side. Yeah, this is your A direction. Yeah, and I'm talking about A direction. Okay, so imagine if we have 8 feet this side and 10 feet that side. Yeah, so 10 and 8. So total means omega A, whatever it is. Yeah, the factor, that's the omega A, times total omega U, value U 1.2 dead load plus 0.6 live load. LA, LB times 8 times 10 means 80. Yeah, times 8 times 10, 80. That's the total load goes to this side. So that's for the whole length. What's this length? LB. Yeah, we call this LB. So if I want to find the reaction at one side for 1 foot, yeah, 1 foot, not for the whole length. This one divided by 2, first of all. Why? Because this part is for the both sides of A direction. A direction means has 2 supports, so that's for the total load for A direction. Divided by 2 for one side. Divided by LB, that LB is 10 feet, will give us reaction here for 1 foot. That 1 foot at either side. Yeah. Okay, the actually chat question. Let me read that. Can you describe the picture for the cases? I think you are asking for these cases. This one is simply support, simply support, simply support means no negative moment. This side, 4 sides are fixed support. It means that the concrete of the slab is poured with the beam, and also the rebar from the beam went to the inside the rebar of the slab. So in this case, you will get something like this detail. Last week, as you might remember, we went through this one. If there is no connection, you can consider that as a simple support. If you pour them together and the rebar of this actually beam went through the slab and the rebar of the slab went through the beam, so you have a fixed connection. It means like that. Or if you have a slab is continuous at 4 sides, so you have a system like this. This is the plan view. Yeah, these are the beams at either side. So if I work on this slab, for example, this is continuous this side, continuous the other side. So even if the beam is not fixed like this for this case, because continuous slab will get negative moment, you should go with this case. Yeah, remember. So if that's the end span of the slab, just you can consider that as a fix when the concrete and the rebar went together from a slab. And let me see if there is another question, because I saw the chat. Perfect. Okay, so I think you got it. Very good. So if it's not that clear, still ask me and I will go through this one. So one more time, for total load, this W is the total load at the A direction, total load at the B direction. So omega A, we read this from this table, times omega U, 1.2 dead load, 1.6 live load, times LA times LB, I consider 8 and 10. divided by 2 because you want to find load at one side. Yeah, this slab has 2 sides at the A direction. This divided by 2 will go us at one side. Then I want to find the reaction for 1 foot divided by total length of the A direction. Total length of A direction is LB divided by 10. So this is the reaction here. Then you should consider this beam, yeah, with this reaction that we calculated here, reaction calculated here. The length of this is this one. Look at this. Span is 8 feet, and we calculated this, and we know the uniform load is omega u, 1 dead load plus 1.4 live load. You can find omega u. Then you saw that for the shear for one-way slab, D support, find the shear. Yeah, so that's the shear diagram. Shear diagram, you D from face of the support. This one means minus D times omega u. That's that easy. Reaction, this is your RU. How can we calculate this RU from this equation? Omega A, omega U, LA, LB divided by 2 divided by LB. So that's your RU for A direction. D from face of the support, so RU minus omega U times D. What's the D? D if that's the cross section of your slab. Yeah, a slab is about 6 inch, for example. So the rebar here, distance from here to the top, you might remember, at least it must have 1 inch from center to the bottom, yeah, 1 inch, or 3/4 to from bottom of the rebar to the bottom of the slab. So whichever is greater. So you have to go half of the diameter plus 3/4. Consider that if it's more than 1 inch, go with that one. So if it's more than that, so 6 minus that. If half of the diameter plus 3/4 is less than 1 inch, go with 1 inch. So 6 inch minus 1 inch. Always go with the maximum 1 inch and half of the diameter plus 3/4. So which one is greater? Total H minus that is your D. Yeah, D from face of support. So RU minus D time, because this is kip per foot, so RU minus D divided by 12 times omega U. That's your shear at one D from face of the support, and then go and do the calculation for the shear. And that's it. What about the B direction? Do the same on the other side. So in this case, omega B means this for any case LA over LB, whatever. For example, here, omega B times omega U times LA times LB. That is will change is this one. Then divided by 2 because you have 2 sides, one reaction here, another reaction there. Then divided by length of B side. So this one for B, length of that is LA. Instead of 10, divided by 8, divided by LA. So you will find for 1 foot of this, that's your reaction for 1 foot. Do the same, D from face of the support. Instead of this 8 feet, you have 10 feet because we are talking about this direction, B direction. And that's it, do the same. Any question on this one?
Professor, can you go back where you were showing how to calculate shear, please?
Sure. You calculate U. This is the RU. We calculated this divided by 2 divided by LB or LA. You will find reaction at either side. That's your RU. D from face of the support. Okay, D from face. D, you calculate this thickness minus the maximum of 1 inch and D diameter of the rebar divided by 2 plus 3/4. whichever is greater. So 6 minus that one, that's your D. Divided by 12, because that's inches, omega is pound per foot. This reaction is pound. So reaction RU minus 12 times omega U is your shear. So you can calculate your VU. VU is equal RU minus D by 12, convert to feet, times omega U. That's it. That's your VU. Then go find capacity for the concrete only. That's 2 lambda square root of prime C B times D, and D is D, and B your 12 inches, because we calculate everything based on 1 foot. So your B is 1 foot. Yeah. So you can calculate that one for 12 inches, and then times phi, because that's VN, your, or VC, that's nominal, times phi. You calculate that capacity for shear for concrete only, compare that with this one. If it's greater than this, 99% of the time is greater than this. So you don't need any shear reinforcement. If it's less than this, you need shear reinforcement. And for the slabs, in this class, we are not working on if you need that shear, because that's for very critical cases that you might need shear. And but you have to install vertical rebar. It's not that hard. You have to install vertical rebar as the shear at the location that you need. Exactly the same as that system that you calculated. Number of this at each. So if you are using, for example, 2 number 3 vertical, your AV is 2 number 3. Your S is a spacing between these, exactly the same as the beam. Yeah, but it's a little hard to install them, and because of that, we are not going after this in this level. And as I mentioned, 99% of the time, there is no need for shear reinforcement. And if there is a little of a need for that, go and add a little bit to the thickness. Instead of 6, go with 6.5. Then see if it's acceptable or not. Okay. Any question on this one? Okay. Still, if you notice, you actually see you have a question, we back and work this part as well. Okay, let's go after example. And this example actually is very easy. Just read the numbers from that case. We have a rectangular slab, and we have a spandrel beam or rigid connection. Spandrel means the beam and the slab put together, and the rebars are connected to each other. So they went inside each other. So it's like a rigid. Or if it's continuous at 4th side, the same. So in this case, we have to go and find for A direction, Y, because LA 10 feet, LB 12.5 feet. Yeah. So LA minimum, LB maximum. Okay. So which case should we consider for this when we have 4 sides rigid? If you go to this table, because we have to pick the right one, as you can see, 4 side rigid means case 2. So we are in case 2. That's it. So at first, just find the cases. Then dead load and live load, M, LA over LB over 12.5, 0.8. Then find omega U, 1.2 dead load, 1.6 live load. This is good for negative moment, because for positive, we have 2 tables, one for negative, one for dead load, one for live load. But for negative moment, we have 1 table, we just the dead load and live load together. Okay. With this case, we have M.8, and we have to find CA and CB, CA negative, CB negative. Let's go to negative moment. That's the moment for the live load. And 0.8 yeah, 0.8. As you can see, CA negative 0.065, C negative 0.027, okay, 0.065, 0.027, 0.065, 0.027. Those are the numbers that we read. We don't need to consider any negative sign or nothing. Just I put this negative to make that clear that we are talking about negative moment at A. So negative A direction, negative moment, negative moment. About these two negative moments. Okay, and for B direction, this is B direction, negative moment, negative moment. Okay, how can I find that? Let's answer a chat. We use the negative moment chart because each side of the slab is a fixed support. That's correct. At first, you have to go with this, yeah, based on the slab that you know you have, you want to design. This slab has 4 sides rigid, so it's case 2. Then I started with negative moment first. Then I went to the M negative, and based on that, I read CA negative, CB negative. Yeah, these are steps that I picked. You can start with M positive, but over here in this example, I started with negative moment first. Okay, and the equation, the factor from that table times omega u. What's the omega u for negative? Dead load plus live load means this omega u. It's not for dead or live, it's omega u. Okay, LA square. So this CA negative times omega u 104 PSF times LA square, minimum length in the power 2. You will get this. And do the same based on the equation times LB. As you can see, LB is greater than LA, but the factor is not. And most of the negative moment went to A direction rather than B direction. And we knew that if it's very long, so the whole load will go at one direction. It will act like a one-way slab. Let me answer this chat. Was dead load and live load given in the problem? Yes, dead load and live load are given in the problem because you as a designer, you know this stuff. Yeah, look at this dead load, 20 PSF, live load, 50 PSF. So you will design the structure. So you know all this stuff. Then calculate omega u based on 1.2D plus 1.L. Yeah, have all the numbers here. But if still you have question, it's better to ask a question and you cannot follow this example that well. Okay, so hopefully so far it's clear. If it's not, please let me know. So as you can see at the LA at this direction, even the LA is less than LB, and each one is in the power 2, still negative moment at these two sides are bigger than the other sides because the load will go to the lower distance sooner than the long distance. Yeah, that's the method that the whole structure is working. Transferring the minimum transferring actually load will pick the minimum transferring length. So this case, most of the load will go that way, and you can see that. Yeah. So that's the moment that we have. Then go after positive moment. For positive moment, for A direction and B direction. For positive moment, you know that we have dead load and live load 2 table. So we will go with omega u dead at first, 1.2 times dead load. We have dead load, 24. Dead CAD, DL, and CBDL. For what case? Case 2 again. Let's go to this one. For dead load only, look at this. I will go to this M positive, dead load only. So for LA over LB, 0.8 because we calculate that. And case 2, look at this. This is case 2. All of them are case 2. We have fixed support at 4 sides. So your CA dead load is 0.024, CB 0.012, 0.024, and 12 for dead load. Then we have to do the same here for 0.8 and case 2, read for the live load. So I'm not going to back here again. Just remember, we have to pick MU positive for negative and for dead load and live load for positive moment. So we can read these two numbers here. Then, as you might remember, we let me go again to read these two numbers from that table to make sure that we have the correct one. M positive for the dead load, you have 0.026 and 0.011. Yeah, these two. I read by mistake for 0.85 because I thought why the numbers are not matched. For 0.8 is 0.026, 0.011. Okay, let's back to the example. CA dead load 0.026, CB dead load 0.011. What's the factor that we read? Times omega U dead load times LA square or LB square. That's it. So MUB means positive moment, MUA at A direction, positive moment at A direction is equal the factor 0.026 times omega U for dead load times LA square, and do the same for omega UB CB, that's times omega U dead load times LA square. As you can see, positive moment is more than the other side because the shorter the span, the bigger the moments are. That's the, if you see something opposite, it means that you consider something wrong. Yeah, just remember these are important. Okay, then go and do for the live load. Omega U live load 1.6 times L. We have L on top here, we have that. So we can calculate it. Then go to the second table for the live load M positive. You can read these two numbers and do the same. And then what's the maximum MU positive for A direction? MU dead load at A, MU live load at A, add them together 62.4, 328. That's the maximum MU positive for this strip here. And for B direction, add the other two together. That's and what's the total shear? If you go to the last table here for 0.8, look at this 0.8. 71% of the load will, sorry about that. 71% of the load will go to this direction, A direction, and 29% will go to other side. And the total should be 100%. 0.71 plus 0.29 is 1. All of them must be 1. Yeah. So 0.71 and 0.29, as you can see, 0.71 for A direction. So omega U is that omega A times total omega U dead load plus live load. We calculated on top, times LA times LB. That's the total load for the A direction. Yeah. As you can see, that's for both sides. I showed that this load will go at the A direction, and A direction has two supports. So for both sides. So shear at one side of the A direction should be this one divided by 2. And then for 1 foot divided by LB. So at the end, you will get 369 pounds per foot. That's the reaction for a beam with LA length. That's a RU and RU. And D from face of the subpoint, we went through that just with omega U on top. You calculate D, and then RU minus omega U times D divided by 12 is your VU. Compared VU with VC times phi, and 99% for this class is always less. So no shear reinforcement is needed. Yeah, and go do it the same for the B direction, exactly the same, but with this coefficient. Yeah, as you can see, this table is, this method is very good and very easy to use it, and you can for any shape that you can or simply supported. So you can go with this method and find the actually results. Okay, that's it. I gave you all this information that I wanted, and thank you so much for being a good student. And right now I'm for answering your question. Will the case number given questions? No, 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 no. You must pick the right case. Remember, yeah. So I'm not going to give you this case is case 2. No, based on the support, I give you simple support, simple support, simple support, fixed. Then you have to go to see which one is that one. Simply support at the short side, both sides, and one side of the fixed support, B support. This is the case. You will be case 6. Let me answer the question. Yes, I saw one raise hand.
Yeah, I was just
what's
wondering
the question, Alexander?
how do we determine if no shear reinforcement is needed?
So you have to calculate V at VU at D from face of the support. Then go and find VC. VC, we solved one example for one-way slab last week. If you see that, just review that, you can see V is equal to lambda root of F prime times B times, and B is for 2-inch. Yeah, B, we will go with 1 foot of the beam. So 1 foot. So times 12. D should be thickness minus 1 inch, or maximum of 1 inch, or diameter of the rebar divided by 2 plus 3/4. So you have D, you have B, F prime C 4,000 psi, 5,000 psi, whatever it is, times lambda for normal concrete one, times 2. That's VC. That's a nominal shear strength of the concrete only. Times phi for the shear, you have that VU strength. Compared VU strength with VU D from face of the support. If that VU from the concrete is more than this, there is no shear reinforcement required. So if in an exam I ask you, check if the shear reinforcement is required or not, that's it. I'm not asking you to find the shear reinforcement. I'll ask you if shear reinforcement is required or not. That's it. Then you have to calculate this. You cannot write yes or no. I'm not giving any point to that one. You have to show why yes or why not. Based on what? The way that I mentioned, find VU D from face of the support and find VC for the concrete times phi, compare these two. If VC times phi is greater than that, there is no shear reinforcement required. That's it. Okay, I think I saw some chat. Let me go and see. Can we set up one last office hour for this weekend? Actually, for this weekend, I am very, very busy because all the classes ask for something like that. I have 3 classes, so I can't say no, but please, if you have a question, please let me know, because I'm not sure if all the class they want meeting for actually this weekend or not. If everybody wants this, then I'm going to give you a time and I will email you. Yeah, but before that, please let me know if you want. But if 1 or 2 ones and there is no not that much a student, then maybe just I can go as soon as I see that, I will go on Zoom and I will ask those 2 guys to come over and ask their questions. Please let me know. So that's another question. Is it possible for you to give either another example or a homework problem similar to the example for this lecture, so we can, yes, why not? Please do for homework for this one. Do the same as this question. Yeah, please redo this based on if, let me find this one, another one. Yeah, for homework, you can go with this system, assume if if LA, just we can go with this one. Please solve this one. LA is 12 feet and LB is 18.46 feet. And it doesn't matter, you can go with dead load equal 20 and live load equal 50. PSF, pound per square feet. Yeah, that's 50. And this one, PSF. Yeah, please redo this and consider this case. For the case that you are going to solve, to actually make that a little more interesting, I will go with this shape. Consider this side fixed, this side fixed, this side fixed. The bottom side is simply support. So 3 sides, both short sides are fixed, top long side fixed, the bottom long side simply support. So fixed, 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 simply support. Yeah, with this information. Please redo this example. Good enough?
Yes.
Please write this. Perfect. So please write this down because I can, oh, maybe I can answer the chat. Yes. So perfect, perfect. So that's a good question and good things that you ask, and very good. Thank you. So let me read another. I'd like to have a review session as well this weekend. Just look at this. I think I can give you about maybe half an hour for the weekend, because as I mentioned, I have the other classes and they want the same. So I think about half an hour, I can give you time for your questions. Yeah. So you ask your question and I will try to answer your question based on actually the chapters that I mentioned. I'm going to have questions. So is there any other question?
Oh, yeah.
Please go ahead, one by one. Okay, start.
Okay, I was just wondering if you could list the subjects that will be on the exam. I know you sent us an email with the chapters, but some of your slides don't have chapters in their titles.
Look at this. Those are actually clear for the chapter 4 is for beams, yeah, flexural strength, and then another one is for the short column, then another one for a slender column. Those are the other chapters plus this slab. That's it.
Okay, thank you.
Good enough.
Yes, thank you.
Perfect. Okay. Any other question?
Yeah, Professor, just really quick, I just wanted to confirm. So the way you described our homework problem, like you were saying that the 3 sides are fixed and the bottom one is supported. Is that how it'll be presented on the exam? Because I'm just trying to, I kind of want to practice figuring out the cases, if that makes sense.
That's correct. In the exam, if this is one of the questions, yeah, then I will show you, for example, for this homework, I ask you to do something like this, yeah. So in exam, I'm writing fixed or simple, or I'm showing this kind of shadow for any side. So right now, based on this, oh man, what's that? So based on this is fixed support, fixed support, fixed support, simply support. That's it.
Okay.
Yeah. And based on this, you should go to the table to see what case is matched with this one. And that's it.
Okay, thank you.
You're welcome. Okay, other question?
I have a question. So if M is like 0.83, do we interpolate?
That's correct. That's correct. But for sure, in the exam, I'm not going to actually give you something like that, because I'm not going to check if you can do the interpolation for this case. You know what I mean? I'm looking for another bigger, actually, result. So, but in reality, in your real life of engineering, if you have such a case, if you have 0.83, then you have to go between 0.8, 0.85, and then pick between those two. You have to do more work. But at very end, you will get one factor for 0.83, another factor for 0.83. That's correct. Did I give you the answer?
Yes, thank you.
Perfect. Very good. Okay, other question?
Do we have lab today, Professor?
No lab. That's a good question. No, actually, we are done with the lab, and I prefer to give you more time to do the study. As you saw that I just minimized the chapters, and I would like to see very good grades from you guys. Just show yourself that you can do it the same as what you did on the second exam. This time, do even better. Yeah. And that's it. And I didn't ask for all the chapters, just I squeezed them to maximum 4. And this last one, as you can see, is not that hard. And we went through this almost 2 weeks, and hopefully you can remember those very well. So let me read another one. Will we be tested on bound, anchor, or development length? As I mentioned, based on those chapters that I gave you, no. No, there is no answer. There's no question on those part. Okay. One more time, thank you for this semester. I enjoyed this actually class, and we started with hard time at very start, and then it got better, and I know that the final should be even better than the last time, and I wish success for all of you, and I'd like to be in contact with you in future. And still, even if you graduated and you have questions, I will be here to answer. And always you can, for any question that I can answer. So let me read this actually chat. Do you know how many questions you'll have on the final? Please, no. Maybe I am giving you one question, but it has multiple parts. So it has a slab, but then in the slab, I give you beam, so you have to go after beam. So because you have 2 hours, so I will give you that many questions that you can do it with good time. I'm not going to push you in a very hard time to solve the example. I will give you actually enough time. I think I will go with maximum 3 questions.
Okay, and just to make
Okay, so
sure,
yes,
so for the cases, the shaded parts or the shaded sides are the fixed, and then the ones that are not shaded are the simply support.
that's correct. That's
Thank you.
correct. You're welcome. So for the extra hour class on weekend, I will email everybody hours. I think about maximum maybe 1 hour. I will try to give you as much time as I can. So I will post. I will email everybody that hour and the date. Then you can actually come to the if you have any question. Yeah, those are just for question. I will be there. You ask your question. I will give you the answer for your questions. And thank you for the chat that I received. So if you have any question, please ask. If you don't have any question, have a great rest of the day. Enjoy your life, and see you on weekend for that extra hour for answering your questions.
Thank you, Professor.
Thank you.
Thank you.
Thank you. Thank you. Thank you.